Good morning. We've already been through the round of selecting a scribe, and Stuart is the scribe. You're sitting where? Over there. Yep. Welcome, as I said earlier. This is the second of our TSVWG meetings. I'm Gori, and this is Martin. Hi, Martin.
Hello. Good morning.
And Martin's going to run slides for the meeting. Maybe do this up here just for fun. This is the Note Well. It's still as important as ever on Friday. If you haven't looked at it recently, please visit it again. All discussions at the IETF are subject to the IETF Note Well and legal provisions. It's important to observe the rules for anti-harassment and all the IPR related and other topics which the IETF thinks is important. Please check this out. Next slide. And here's our agenda. Do we have anything particular on the agenda we want to highlight, Martin?
No changes since the last session. So unless there's any agenda bashing from the room, we're good to go.
Okay, so there's a set of drafts. These are all the active drafts. Some of these drafts have completed a working group last call, and we are now presenting them to make sure they are finalized in appropriate with the consensus of the group. And some of this is work that's being started, and some of this work is ongoing. Any changes to the agenda requested now? I'll draw your attention to item 7. This is a new draft. If you haven't looked at it and you want to look at it before we present that, that will be good. We'll do a call for how many people have read this when we come to it. Next slide.
There's no next slide.
That's right.
So we can jump to NQB.
I want to control. Does that have control?
Do I need to do anything?
I'm not sure how to do that in the app, to be honest. I just do this.
I can just drive.
Okay, that's fine. All right. Okay. Good morning, everyone. To all the folks who have stuck around for Friday, give an update on the NQB draft. So we're at version 24 on the data tracker. I'm Greg White, Cable Labs, presenting on behalf of my co-authors, Thomas and Rudiger. Next slide, please. Status of the draft is we ran a first working group last call in end of 2022 and into 2023. And that was on, I believe, draft 16. There were a number of, maybe it's draft 19 actually, number of updates since then, a number of comments were received there. Draft was improved quite a bit with lots of good comments and review that round. And so we ran a second working group last call, which ended just a few weeks ago on draft 23. I believe it ended on June 10th. After that, the early review came in with 3 comments, 2 editorial comments and 1 question. That was towards the end of June, and we have a milestone to submit this as a proposed standard RFC by August of this year, which is coming up very shortly. And in terms of deployment, Comcast has started a field trial using this PHP in their network. as of October last year. And then they announced interconnection of the NQB code point starting in February of this year. So they're connecting with their partners, receiving NQB marked packets and delivering them all the way to the end user for residential broadband services. Next slide, please. Oh, and Jason will be coming up after me to give a more detailed update on the status of that trial. The outcome of the working group last call, there were approximately 80 mailing list messages from more than 12 contributors, a few invited reviewers as well. So thanks to everyone who read through the document again and or for the first time and sent their comments. Many of the comments were relatively easily addressed, and those were addressed in draft 24. And there were 5 remaining issues that I entered into the GitHub issue tracker so that we could work on them and get them resolved for publication of the draft 25. Next slide. In terms of the deltas and what was added after the working group last call, so draft 24 added a new section 3.4 labeled applicability, and so that brings together text that had been scattered through the document talking about the applicability of the NQB PHB, brings that into one place, so it's more easily found. In section 4.1, made a clarification that 4.1 talks about the sender requirements for marking traffic with the NQB code point, and a requirement is intended to be that the application flow is sending at less than about 1% of the expected path capacity. And knowing that that's a fuzzy term, but that's what we agreed on as a working group as a good way to describe it. But we provide an example with today's network saying that that's approximately 500 kilobits per second. And it was a little bit unclear that whether the 1% was the requirement or the 500 kilobits was the requirement. And so clarify that that was intended to be an example, not a requirement. Also, there was a rate formula that talks about the smoothness of sending, which specifically mentioned 1,500 bytes. Change that to 1 MTU instead of 1,500 bytes. Section 4.5 talks about tunneling protocols and particularly the use of reordering sensitive tunneling protocols. If a tunnel contains a mix of traffic, some of it marked, say, default, and some of it marked NQB, those go in separate queues in a NQB PHB instance, so they could arrive out of order. If that tunneling protocol is needing the packets to arrive in order, that could cause some problems. So the guidance in 4.5 now says, if you're going to do this, you should, on the outer header, mark with a single DSCP so that your packets don't get split into multiple queues, into the 2 queues. All right. Added a new section in 7.3, so 732, which brings together all of the updates to RFC 8325. These had been specified just kind of in line in the document that implementations of RFC 8325 would need to do X, Y, or Z. We hadn't completely spelled out these are the text changes in 8325, so that's been done now. And then other minor editorials. Next slide, please. The 5 issues that are in the tracker. These, many of them, I think, we're basically finished with. So the first one is there's a discussion about the intersection with L4S, and there is a requirement in the NQB draft that says what it was intended to mean, if a network node is implementing both L4S and NQB, then it must do this specific thing. But that wasn't super clear, and so it was misinterpreted as being an additional requirement on L4S that's separate from NQB in some way. So made that, have proposed text to make that more clear, so that we don't need to update RFC 9330, 9331, because they already cover the intersection with DSCP. That's fine. This one new requirement, again, only applies if an implementer is implementing NQB. All right. So that one has proposed text. 46 was ended up being somewhat editorial. At the end of the day, actually 46 and 47 related to one statement in the document that talked about minimizing incentives for mismarking of traffic. Two kind of separate thoughts on problems with that statement. So we have now a proposed replacement sentence that maybe doesn't promise more than it should. So that's 46 and 47. 48 is, there's been quite a bit of discussion on the mailing list and in the GitHub tracker on this one. Should traffic protection be mandatory to implement? I think we're beginning to converge. There's still some discussion to be had, I believe, but I'm confident that we'll get that one resolved fairly soon. And it's all about kind of what is necessary for the IETF to mandate versus recommend to ensure that bad things don't happen in the network that implements NQB. Issue 49, should we explicitly document the use of DSP5? So there was a question about RFC 8100 interconnections, and in those interconnections, the recipient may want the NQB traffic to arrive with a code point that is that the top 3 bits are 0, because there's some bit masking that goes on the receiving side in RFC 8100 interconnects. And we had in the work group talked about potentially documenting the use of DSCP5 because it's effectively taking the 45 value and stripping off the top 3 bits. Recognize that was problematic to list 2 code points for a single purpose in a standards track draft. So we've got a proposal of just making the statement of if RFC 8100 is operational, the receiving domain may prefer a different DSCP that allows for range-based classification. So hopefully that suffices. I see David is in the queue. Do you want to ask your question now, David?
More of a comment, Greg. So for those who haven't figured out, I'm the one reviewer in issue 48. And Greg, I think, let me see if you agree with this, discussion on issue 48 is now headed in the direction of what needs to be done so that traffic protection does not need to be mandatory. And it looks like that splits into 3 subtopics, which can be oversimplified as incentives, security, and Wi-Fi. I'll leave it to you to decide whether to break those out as separate issues or leave them sort of all bundled into the 48 mega issue.
Okay, thanks. Yeah, thanks for your comments on the mailing list and articulating your concern with that with traffic protection. Yeah, let me take that offline to decide whether it's useful to split that out into multiple discussion threads. Yeah, thank you for that suggestion.
Okay.
Jahid here. I actually think like it would be nice to divide them too, because I'm getting lost on the discussion. So if we have 2 separate discussions, I mean, these are related, but we can actually conclude 2 separate things, discuss 2 separately and conclude perhaps some same kind of thing, but the discussion could actually help get separated, at least from my point of view, because it's hard to track what's happening.
Yeah,
And I was actually going to up my hair saying, like, can you summarize like what exactly happening, what's the background, and maybe today we can discuss it, but it's up to you how we run it. Yeah, it's a sensitive thing.
Yeah, okay. Is there a time for a more detailed discussion during the slot?
If you, okay, so I think I'd like to comment on issue 49 first.
Yeah,
So from
I
my
covered them, yeah.
perspective as chair, it's quite okay to use 2 IETF assigned DSCPs if we have a real need for that and there is some different PHB appearing for that. And I think in this case there isn't. So I think
Right.
in this case you shouldn't be using DSCP 5 unless you find a good case for that. Currently that's off the table, I think.
Right, right.
Okay, so back to issue 48. I think the chair's position is how you summarize at the end of your slide deck, which is we would love to see a proposed resolution to this from the document editor, which you think adheres to the working group consensus. So if you want more time to talk about this now, that's fine. If you want to liaise with the people who are discussing this on the list and then come up with text, that's also fine. So take questions if you want on that one.
Yeah. Well, does anyone have, well, okay, maybe I should provide a little bit more background on 48 and then see if there are any comments from anyone in the room. The draft makes the assertion that the NQB code point is designed in a way that provides a shallow buffered best effort queue that is intended to sit alongside a default deep buffered best effort queue. So traditionally in access network links, so this NQB is primarily intended for access network links, so keep that in mind at the beginning. Traditionally, these links have a single deep buffer queue, works great for classic TCP protocols and other protocols that may send bursts of traffic, and they would much rather that the bottleneck link queues them up and plays them out across the link rather than dropping them on the floor. There are all sorts of other applications that have become more interesting as of late, real-time applications that don't want a deep buffer in the network and would prefer not to be subjected to the queuing delay caused by a deep buffer in the bottleneck. So the assertion is that if you have 2 queues, they're equal priority, one has a shallow buffer, one has a deep buffer, you can let applications decide which queue works best for them. There's not an incentive for an application to try to steal anything, to try to get its traffic into the wrong queue. As compared to some historical mechanisms that have been used to deal with latency sensitive traffic, say giving a high priority queue like expedited forwarding. There you've got to now police that the traffic that marks itself as expedited forwarding, it really deserves to get high priority. So NQB tries to sidestep that prioritization issue by saying you've got 2 equal priority queues, again, shallow and deep buffered. So the assertion that the draft makes is that there's no incentive for an application to mismark its traffic, but sometimes bad things happen. Sometimes there are malicious actors that might try to disrupt communication. So it is recommended to have a mechanism that tracks the applications that are, or flows that are classified into the NQB queue. And if a flow is identified that's causing issues, redirect that traffic to the classic queue. And so the nut of this issue is, should that traffic protection in fact be mandatory, or is it okay for it to remain a recommended implementation? Should. I guess the arguments for keeping it a should are, there are networks where there is policing of code point usage. Your enterprise networks, for example, networks where the ISP even manages the code point marking in their network before delivering it into the customer's network in the case of access networks. Um, and while this functionality is a good one, this traffic protection functionality, we recommend it. There are cases where it may not be necessary. I see David's in the queue. Do you have a comment on that?
All right, I'll do my best to play His Majesty's loyal opposition. So, Greg, I certainly agree with you that the design goal of this PHB was that there be no incentive to mismark traffic. However, I don't think that I think that remains a design goal or aspiration. I don't think it's been achieved, mostly because shallow buffered is effectively an undefined term in the draft, and I think it's emerging from discussion that we don't understand the details of exactly how to configure a shallow buffer to get to completely remove the incentives. Not clear to me that we have to. So that's on incentives. I'll lump security together with class of equipment because I think this discussion is very close to agreement on the class of equipment that motivates this. There are means other than traffic protection to contain traffic that is doing stuff that it shouldn't with this PHB in a fashion that the abuser effectively only damages themselves. And I think somewhere in there, there's a way forward where, at least for the class of equipment on which the deployments are happening and that motivate this, traffic protection is not would not have to be mandatory. Um, Beyond that, I don't know what we do, whether we uh, limit applicability to that class of equipment, or say if you don't have these other protections, then traffic protection is mandatory. And then existing Wi-Fi is a special case of that which has been a target for a long time and still doesn't appear to have any really good, yeah, this completely solves the problem answer.
The point that's been made on the mailing list is that this is a best effort service. And yeah, attacks can happen on best effort queues. They should be mitigated. Having tools to do that is a good thing. That's why it's a recommendation to implement traffic protection, but it is a best effort service. So that's another piece of it. Yeah, I think the Wi-Fi part is, that has been discussed quite a bit over the last few years on the mailing list. We've selected a code point that in existing or many existing Wi-Fi networks gives the NQB traffic a separate queue from the best effort traffic. It also is a queue that by default is high priority, which is not the intent of the NQB PHB. But we made the judgment call at the time that that the benefits outweigh the disadvantages, that providing the benefits of a separate queue for NQB mark traffic trumped the potential downside of applications using it to try to get high priority. And one of the biggest rationales for that is that these Wi-Fi devices give high priority to fully half of the diff served code point space. Anything with the most significant bit of 1 gets high priority. So there are all sorts of other code points that an application could use to get high priority in Wi-Fi. Using NQB specifically would mean that you might get high priority if you're going across a legacy Wi-Fi network, but you might not, because the recommendations in the draft are that the NQB code point not be given high priority going forward. So it seems as if it actually is in line with the incentives. So
Yeah, I'm not at all sure about that, especially because there's at least one sentence in the Wi-Fi portion of this that is addressing this that I regard as just plain unrealistic. As I said, I think Wi-Fi is a tar pit. I don't know that we're going to come up with a perfect solution for it, but I would suggest making sure we've got the other two solved, namely that we've got a correct statement of the incentives based on understanding and or lack thereof of specifics of queue configuration, and that we get at the security stuff at least worked out for the classes of equipment that you and Comcast and the other folks working with this really care about, and make sure we've got that nailed. 'Cause it doesn't look like we've got a fully general statement that would apply across the board to all classes of equipment.
Okay. So like to move on to Martin.
Hi, yeah. 2 points. One, well, a point and a question. First of all, I'd encourage us to not spin out on this question. The difference between must and a very well-written should with very specific exceptions on when it's okay to do something is quite small. Added to the fact that like Edge Network's going to do what Edge Networks need to do. Like they probably don't need to be told to do something if their networks are threatened. And we're not the protocol police, so like by all means let's discuss this, but let's really time box it and not hold up the document for too long. Is traffic protection always and solely a matter of taking traffic and putting it in the normal like best effort queue, or are there other mechanisms like bleaching and dropping that are incorporated in that concept?
Thanks. Yeah, it does include options to discard traffic that's been identified by the traffic protection algorithm, as well as when you're moving it to the classic queue or to the default queue, it's optional to remark it as default as well. So
Okay.
Those options are given.
Like I'm a little more concerned about that with more something like dropping is obviously much more costly to the client, and I'm concerned. I'm from Google. Like I'm thinking about Google search. I'm wondering, Google search is not really a particularly queue building application. I'm considering maybe we should just mark NQB as a rule. Like I don't. It's just not a considered opinion. It's just something that's occurring to me. So don't hold me to it. But like it would be a real problem if we're in putting these mechanisms where those sorts of packages are going to get dropped if we happen to catch them, if we happen to cross some sort of threshold that is somewhat obscure. So to the extent that's what we mean by traffic protection, that's much more a problem than like going the normal queue is fine. Bleaching is like okay. Dropping is, in my opinion, bad. Thanks.
Okay. Yeah, and I believe that the draft does recommend higher thresholds for doing the packet drop option. I'll take a look and double check that. We make that clear.
Pardon the interruption, Martin. If the shallow buffered queue is correctly configured as shallow buffered, I think you run exactly the risk you've described, which is that if you somehow exceed the threshold that you can't see on that queue, you'll get drops.
Right. So I'm fine with like by definition, a shallow buffer queue is going to result in drops when you exceed the bandwidth by by some amount. Like that's obviously a property of this, and that is fine. But if like if there's some sort of larger mechanism that is kind of like labeling me bad and starting to drop my stuff, that is a different matter.
Okay. Thanks.
Matt Mathis here. Making it mandatory feels like a barrier to deployment. And in the absence of strong evidence of a failure of incentives, I would not make it mandatory. I think it's sort of a waste. There's actually another attack that you could use, another defense you could use, and that is for devices, hardware that can do virtual queues at line rate, you could unconditionally delete the duplicate match, which would enforce it even if you're not otherwise loading the system. And I know there are a lot of router vendors that do have hardware that can do that kind of thing.
Okay, maybe I'll follow up with you offline and see if we can.
Yeah, I would recommend saying something fuzzy about in the absence of any evidence of cheating. This is probably not important, but people should be prepared that it might be needed.
All right, appreciate that. Thanks.
Yeah, Matt, I think the discussion has evolved about as you would like to see, which is it won't be mandatory, and we need to figure out what the right text is to write about to write about its role or remove because it's not mandatory.
Okay, so I see a few things here. We've closed the line, so we'll stop the discussion on this one. I see that it'd be wise to separate out the Wi-Fi case. It might be wise to clarify a little bit what options we have for managing here. I mean, so they're written in the draft, but maybe they're not quite so crisp in that particular place. And I think we can recommend the editor to work with other people to try and come up with text that resolves this issue. It looks like we're on the way to getting there.
Okay, appreciate that. Do you have two more slides, I think, just to wrap things up. The early review, the 3 comments. 2 of them have already been taken care of in draft 24. The first one involves, again, that 500 kilobits per second. Even with the improvement made in draft 24, it's still, in reading it with fresh eyes, could be, the rate equation could be misinterpreted as referring to the 500 kilobits number. So another, just swapping the order of 2 sentences in order to resolve that. So hopefully that solved that one. Next slide. Next steps. I think we've covered that already. So yeah, that's it.
So when do you expect to deliver a document with 25 in? Are we talking about weeks, months, years?
Hopefully it is a week or 2.
Excellent. Good answer.
Thank you.
Okay, so that took slightly longer than we budgeted in our agenda, but we think we're still running with the schedule for speakers having the time. So the next one up will be this man here. And you don't have slides, is that right? Oh, you do have slides.
I do have slides,
Look at
yes.
this, look at the slides.
Yeah, I can only thank our marketing people that, I just use a plain white background. So next slide. My name, by the way, is Jason Livingood from Comcast. An update on our dual queue trial. So first, thanks to our partners, in particular to Apple, NVIDIA, and Valve. They've been invaluable in giving us app layer QoE feedback, and they have employees that are participating in the test that are able to give us feedback as well. That's helped a lot. In particular, some of the feedback from Apple that helped us iterate some of the boot file configuration settings that we're using right now. Next slide. So here are the 3 questions. What network areas are we going to deploy in, on what devices, and when? And that's sort of where we are in the trial. So next slide. So the first thing that we're doing is we are deploying on what's called our virtual CMTS platform. So we have 2 different types of CMTS, which is the next hop from the cable modem. The integrated CMTS, or the sort of old school routers, big chassis, line card kind of thing. Those are end of life from our standpoint. We're migrating everything to virtual CMTS, which is a new virtualized platform. And it depends as well on this new digital fiber node. In many areas of the network in the past, it's been an analog fiber node. It's moving to digital, which means from that node, we can go last mile, which is really last block or 2, either EPON, 10 gig EPON, or HFC. And I would say more than half the network today is upgraded to what you see here, and we're pushing that forward. The 2 different areas that you would see in those next gen areas, one would be mid-split, where we've changed the split of the RF spectrum that the upstream bandwidth gets and raised that. So in our mid-split areas, typically you're going to see a 100 or 200 megabit per second upstream instead of something more like 35 megs. And then full duplex areas are completely symmetric speeds, 1 or 2 gigabits per second. Next slide. And just to give a picture, like today, to serve 60,000 homes past that old analog or line card based chassis, you'd have 20 racks doing that. Today, in Gen 2 areas, it's 1 rack, and we're in the midst of doing this Gen 3 right now. So that's a much better situation for us, and we control more of the code base. Next slide. And by the way, that code base control is important because that's how we've been able to add and sort of play with the downstream dual queue support. And then just showing very quickly the inside of the digital node. This looks almost exactly the same as the analog nodes. Essentially what we're doing is we send a technician up on the pole, they flip the thing open, they take like the bottom cover out, and they are just putting a new, basically a new shelf inside of it. So it's a very quick thing, and it gives us a whole ton of benefits, which is awesome, among which is you can go 10 gig EPON from there instead of HFC if you need to. Next slide. The devices. So what devices? The first device that we're going to deploy on are our own gateways. They run the software called RDK, in this case RDK+. It is an integrated cable modem plus wireless gateway. The customer can turn that off so they can run it in what we would call bridge mode and use their own home router if they wish to. But it works best when that integrated AP and router and modem are sort of all functioning as one. One of the key reasons that we're launching first on our devices is that we control the code base directly, and we have been, regularly adding, like every single release that comes out, we're tweaking features, tweaking configuration parameters, and so on. And that also gives us the ability to sort of carry some of that dual queue support into the home LAN. In parallel, we have customer-owned and managed retail cable modems that are getting certified. We, in the trial, had a few different devices, the Aris S33 and a few others. We've run into problems with some of those, in part because of the chipset that those devices are running. So we've sort of pivoted on some of the retail devices, and we're now focused on the ones that are ready for our full duplex deployments. And there's a very small list of those right now, but we're emphasizing some of those. And so depending upon our exact launch time, it'll either just be with our devices for 30 days or 60 days, or it might be our devices plus a small set of retail devices. My goal is to have both of those classes of device ready at the same time. At the same time, I don't want to put any critical path dependencies on the devices. And so I think the objective is let each of them go on their own sort of life cycle. And as soon as they're ready, they'll be added. And for us, we have a number of devices, XB8 is the newest, XB7, both of those are going to be ready. And then XB6, we have a huge number of people on XB6s. So that is sort of a fast follow that's in our queue as well. So working to get as many devices as possible. One of the advantages of using some of the newer retail devices that are getting ready for full duplex is those vendors that supply that are still really engaged in doing regular code updates to get full duplex working. And so it's easy to say, slot in a tweak to this or that L4S feature. So that seems to be why that's helping. Next slide. So the $1 million question is when? And all I can say is kind of soon. It would be very soon if it was just up to me, but we're in that final phase for those of you that have done, operator deployments, and the broad permutations of stuff in people's houses and weird things in the field. And so we end up getting to like, okay, we think we're ready to go. And then we're like, oh, we have this one really weird use case that affects whatever, 24 devices. And so we need to go fix that. And then you figure out, oh, that's a really simple fix. Maybe that's a couple lines of code. But the team that has to do that work is like, oh, sorry, we've got this big backlog of, higher priority issues. We'll slot that in 45 days. So we're in that kind of, final dance, which is usually a good sign because things are looking very stable operationally, and you're just into the final things of like provisioning systems, monitoring, and other kinds of, little bugs that we have to hammer down. In fact, some of those that are just totally unrelated to us, but we've got some dependency on a code release in some of the devices or the CMTS. So hopefully very soon. All the feedback from users has been very positive, and I think I've shown in previous IETF meetings the benefits of cloud gaming and so on. We've had a bunch of great conversations here with some new folks that are interested in doing more trials, and hope to see some things there as well.
Thank you. Do you have any questions?
I see one person in queue. Go ahead.
Hello, Jason. This is Suvidas. Thanks for that report. I just heard that you mentioned full duplex. Is it full duplex on the access Wi-Fi part or on the from the device to the upstream?
Yeah, great question. When we say full duplex, we're referring to the DOCSIS network. So
I see.
in the access network, 1 or 2 gigabits per second symmetric over HFC. Wi-Fi, as you know, is a little bit of the Wild West, so to speak. Yeah.
No, that's why I thought maybe you have a device which supports full duplex on the Wi-Fi part. But thanks for the clarification.
Sure.
Matt Mathis, is there a quick way to check for our specific service?
A quick way to check, like,
What the current status is? I mean,
oh, like if
how
you're
close
on,
we are, or what pieces are missing?
if you're a user, for example, like checking to see if you're ready in one of those vCMTS areas, for example.
Correct.
Yeah.
Yes.
The short answer to that is not really. If you run a trace route, as somebody that is certainly far more technically capable, that's like easy, right?
Yeah,
So
I've used traceroute a few times.
Yeah, I figured. But you can look at some of the host names, and when you see the CMTS name, it's going to be very clear that's a vCMTS. But we are working on some sort of quick visual indicator. It kind of astounded me that didn't exist yet. Primarily, the indicator that you'd notice is, did you get any messaging about higher upstream speeds? We're usually very vocal about, hey, you're about to get upgraded to 100 or 200 megabits per second upstream. You might need a new device, et cetera. And that is an indicator that you're sort of in a network that's going to be ready.
Because I did notice an upgrade that wasn't announced.
That
That happened to me, and it was to 1 or 200 megabits.
There you
upstream.
go. Then you're on a
So-
virtual CMTS. Hooray.
Thanks, Jason.
Great. Thanks so much.
And for people who are wondering, the part of the motivation for getting Jason to present here is to facilitate the next work item. And if you're somebody who's also looking at L4S deployment in your network and you want to bring a presentation to the next meeting, then get in touch with the chairs.
All right, next up, the L4S ops draft. For those who aren't familiar, there was a lot of discussion during the definition of the L4S functionality around a particular scenario where a bottleneck link has a single queue RFC 3168 or classic ECN active queue management mechanism. And if that is the bottleneck along the path, and you've got L4S traffic sharing that path with classic traffic, then the L4S traffic will get more than its fair share of the capacity. In some cases, even bordering on potential starvation. A lot of cases, it's far from that, but there are some cases where it could be problematic. During the discussion, no one was able to identify that these bottlenecks actually existed in the internet, but they certainly theoretically could. And so we wanted to write this draft to give guidance for how to detect them, and if you happen to be running a network that has them, what to do about it. So next slide, please. Already covered the scope. So the status of it is that we've not made any updates to it for a while, since 2021, in fact. We agreed as a working group to keep it open as a living document as L4S deployment begins, in case there are additional learnings that we'd like to include in the document. So far, we have not found anything that needed to be updated. If anyone thinks we're missing something, now is the time. Our milestone is to wrap this up in November at the Dublin meeting. So the clock is ticking. If you think there's something missing, please make us aware on the mailing list, and we'll have a discussion. And the last point, this is an informational draft, so it isn't as if once November comes, we cannot learn anything new and we can't give any future guidance. We can always revise the draft, so, or revise the RFC. So, yeah, Matt.
Yes, if it's a living document, is there a reason to close it before you get further into the deployment?
Well, I guess for the reasons that it has sat now for 3 years and we've not detected the need to add anything to it. It certainly doesn't hurt to keep it a draft and keep pushing it along.
And what's the current deployment penetration for L4S?
The only large deployment is the one that Jason just spoke about.
Okay. Which might detect problems and it might not. I mean, there's always a potential that some new unknown interaction between classic ECN and accurate ECN or modern ECN will be discovered. And although it bothers a certain class of people who score internet draft progress and stuff like that to keep this draft open forever, I could imagine a world where the draft is never closed because in fact it becomes irrelevant. But you're not going to know that until you get into significant deployment.
Let's punt on that in Dublin, because that's a good question. And in Dublin, we would like to ask as chairs if we want to keep this document open or if we think that we have enough. This is the important discussion. I mean, the third option is we decide we don't need this document because we have consensus that the issues are fixed. It's informational. We can always publish another one as well.
Remember, that's consensus that there are no bugs.
The consensus?
Consensus that there are no bugs.
Yeah, right. And that's interesting. So it may be easier to publish an informational document and then publish a second one in 3 years' time, which says, since this, nothing happened.
True, true. But I've certainly used internet drafts like a little private wiki that I then threw away.
Okay. All right. I think that was that. Then I do have a very brief update on the L4S interops. Next slide deck. Don't mind. 5.3b. So we've been running an interop a bit. Next slide, please. At this IETF. This is the 5th in the series of interops that we've held in conjunction with the IETF meeting, starting with the hackathon on the weekend and then continuing all week. We have a new sticker as well. The graphic is there. If you didn't get a sticker, grab me after the session. I've got a few left. A lot of people are wanting to collect the full set. So. In addition to the 5 at IETF, Cable Labs has hosted 7 of them at our facility, and we have across that series of both IETF and Cable Labs, over 20 organizations have participated in them, averaging about 30 participants per event. Next slide, please. What got done this time? So the new news, a new set of Linux kernel patches for L4S. That's all the components, accurate ECN, TCP prog, and dual pi squared. There are links there in the slide for kernel 6.1 and 6.6, as well as one specifically for ARM/Raspberry Pi. Second big news is a new open source congestion control object called UDP prog that was released this past weekend. So any application that wants to start using L4S congestion control in built in to the application running on UDP is a great way to do that. It's still new, so bugs might exist. So please try it, send comments. There's also a functionality within it that's intended specifically for video streaming applications that's intended to integrate with the codec. During the interop, that was picked up and integrated into iPerf2. And so there's a feature, I'm not sure if it's fully released yet, but it's very close if it hasn't, that you can do a --UDP L4S or UDP L4S video to run tests that use that congestion controller. In addition, support was added for seeing ECN information in the TCP black box logging in FreeBSD. So that supports not just L4S, but other ECN information as well. And then last, Netflix was making improvements in their simple rate control, which is an L4S rate controller for video streaming. Next slide. Upcoming opportunities. So there's another interop at Cable Labs in just over a week from now. So if anyone is interested in participating in that, registration's open. We do intend to also do one at the next IETF meeting in Dublin. Let me know if you have any questions or comments on that. So thanks. That's it.
Good. Thank you, Greg. Get in touch with Greg if you plan to do some interop testing. If you can go to the Denver interop, the IETF hackathon, or anything else, we'd be very pleased to hear from you. And next over to Martin. I think we have enough time for the DTLS discussion. Let's go.
Yeah, next we'll talk about SCTP. And if you remember Brisbane, yes, Matt?
I'm sorry. I had a late thought about the previous talk, not the immediately one, but about the internet draft. Another thing that we could do is ask vendors of equipment to put warnings in their operating systems about people turning on obsolete options.
Many things are possible.
Okay, back to SCTP. So in Brisbane, we had a pretty long discussion about DTLS protection for SCTP. And if you remember, we had 3 different drafts, 2 from Ericsson, both of them affected to varying degrees by IPR. And then there was a 3rd draft by Michael and Hannes. And that one was not affected by IPR. However, it depended on a document, TLS extended key updates, that was not yet adopted by the TLS working group. And there's an update to share now because it was presented in the TLS working group earlier this week. And all the feedback that had been received earlier by the TLS working group has now been incorporated into this document. And there seemed to be very little pushback on this document in TLS. And the TLS working group is now running an adoption call. The adoption call is still running for, I think, 2 weeks. But there's already been, there's been a lot of support for adopting this document in TLS. So we will probably have an update there soon when the TLS working group comes to a conclusion if they want to adopt this document. And if they do, then the draft can be updated to depend on a possible TLS working group item. Is there anything else you would like to say about this document, Michael? Then we can jump to your other document, which is RFC 4895 bis.
Yeah, I'm Michael Dirksen. I'm talking on behalf of the other co-authors. So this is about the BIS document of SCTP authentication, which is a requirement for the DTLS over SCTP solutions, both of them, the one provided by Hannes and myself, and the other one provided by Ericsson. Next slide. So the original scope of the document was to incorporate relevant changes from an old draft, which was trying to add some clarifications to address two security issues reported by Ericsson, which means one is the use of directional keys, and the other one is don't use the same algorithm, use two different HMAC algorithms with the same keys. Then we want to generalize from HMAC to MAC, which will just be reverting. We will retire HMAC SHA-1 and use a different algorithm as mandatory to implement, and we will add, or we are adding socket API considerations to make the implementation of DTLS over SCTP better. Next slide. So this is the status of the first individual versions, basically editorial stuff and changing to XML v3. Next slide. This is the changes between the document we had at the last IETF and this one. Basically, two things happened. One is there's an error cause you send when you receive an auth chunk using an HMAC identifier you don't support or you don't understand. There was a discussion whether it would be better to just silently discard this. And I think that's true. And so that change has been made. And thanks to Timo Völker, who read the document in a detailed way, there were various editorial improvements. Next slide. This is how this auth feature integrates in the SCTP handshake. So in the init and init ag, you have three parameters. One is a random parameter, which provides a 32-byte random number. That's unchanged. You have a chunks parameter where the sender of this chunk says I'm accepting these chunk types only in an authenticated way. So there's no it's not a negotiation, it's a declaration. And the endpoint can say which HMAC algorithms it is supporting. And we are trying to allow backwards compatibility. So if some implementation is only supporting algorithms from RFC, from the old RFC, and the other side has via the API indicated that it supports legacy stuff, then it will work. But both sides can also say, we don't want to do the legacy stuff, only the new stuff. Next slide. So that was the legacy mode. How do we distinguish between it? All the HMAC algorithms defined in the old RFC will be deprecated. We will have new ones. And if an endpoint announces only the new ones, then it's not operating in legacy mode. If it announces both, then it supports legacy mode, but it prefers the non-legacy mode. And if it only announces the new ones, then it's not operating in legacy mode. Next slide. There are two proposals I'm bringing up here, which could be integrated. And one is the solutions for DTLS over SCTP. It's useful to say, I want to accept only authenticated chunks. So you cannot require authentication for init ag shutdown, complete and auth, but for all the other chunk types. And that would mean you would need to list them all. So the suggestion is to, when not operating in legacy mode, sending an empty list of chunks does not mean no chunks are required, but all chunks are required. So that's doable in a backwards compatible way. And it just makes the handshake shorter because you would have to list, I don't know, 250 bytes there if you don't do this. So that's something which is easy to integrate. It will only work, it will still work with legacy nodes and allow this for non-legacy nodes. Next slide. The other proposal is a couple of people brought up the question whether the replay protection when you're using SCTP authentication should be better than when you are not using this. So the old RFC says we don't improve the replay protection, so you get the same level of replay protection. But this is a proposal to improve this. So when not in legacy mode, you would change the layout of the auth chunk by adding a 64-bit counter. The sender would just increment for each auth chunk it sends this counter by 1. And the receiver would have a sliding window of chunks it's accepting, and it's making sure that an auth chunk is only accepted once, at most once. And this is the same replay protection algorithm as done by IPsec. This only works if both sides are not in legacy mode, since it changes the format of the auth chunk. The question here is, should we integrate proposal 1 and or proposal 2 to improve things? Is there a next slide?
Do you want to take questions now? I saw
Depending on the next slide, because I think the next slide says
Okay.
Next steps. Exactly. So this is what's still need to do. Integrate proposal 1 or 2, depending on the feedback. Changing the text-based description to a more formula-based description, generalize the text, and basically address all comments which will be received. Magnus.
Yes. So on proposal 1, I guess on high level it seems fine. I guess there's already a connection between the chunks and algorithm, which enables you to select which. I mean that you bind to those two parameters together, and the interpretation of it is depending on the other. That's already true for the auth, that both is dependent for auth, so I guess it's fine in this case, but it does complicate things slightly.
Sorry,
so I have no.
It was very hard, at least for me, to understand you. So you are in favor of proposal 1, or you are not?
I slightly worried about the impact on the coupling, but I would guess it's likely to be fine. But it's so I'm indifferent in some sense from that, but I see there's some little risk of some complications due to the coupling between the parameters and their processing. But let's talk about 2 instead, which I think it's a good proposal. I think you should consider just including the lowest X bits in the actual authentication chunk. You don't need to send all 64 in each packet. 32 would be more than enough. In addition, due to the multi-homing, I think you need to consider this. This is something we have included in for the details chunk also, is that because when you have replay protection based on the transmission order, and you're not caring about which path and which destination transmitting, your heart beats for any additional paths will be a challenge in that you will need to have a larger window that covers also the latency differences between the different paths. So your window for need to be large enough to cover those cases. But I'm in favor of doing 2. So
Okay, so you're in favor of doing proposal 2, and they didn't got proposal 1. So maybe you can send that to the list and we can
yeah, okay.
discuss it there. Unfortunately, it's very hard for me to understand what you're saying acoustically. John?
Yeah, I haven't thought about the details of proposal 2, but I think to publish this in 2024 as a proposed standard, I think replay protection is a must. I think the requirements to publish something as proposed standard has increased in the last decades. I'm also missing privacy consideration. BCP is that the IETF should always consider pervasive monitoring in all standards. And here we have a security protocol that have no encryption. You could argue that this is already outdated, but at the absolute minimum, it should have a very clear privacy consideration section saying that, like, basically, this is not really recommended.
So you mean updating the security considerations of the document?
Yes, with privacy considerations, that this is not encrypted.
Sure.
And there are implications for pervasive monitoring.
Any comments regarding proposal 1 or 2? Do it, don't do it. Okay, so I think we discontinue the discussion on the list. Okay, thank you.
And then next we have Magnus with an update on DTLS for SCTP.
Yes. So I'm going to update on both the current working group documents and our DTLS chunk proposal. So next slide. I want to remind you about the IPR declarations that exist for these documents, where there's 2 on the first document. The DTLS chunk has the one which offers a non-license requirement if you fulfill certain requirements when it comes to non-assertion against it, etc. So please read it. The other one is RAND, it's like the other 2. Next slide. Just a short reminder about what the DTLS chunk and handshake looks like. So we call this DTLS in SCTP. The DTLS chunk is basically DTLS record processing inside the SCTP stack between the basic packet arrival handling and the actual chunk parts. And this is keyed from a higher layer where the DTLS run DTLS messages for key management and session establishment, and then push these keys into the record processing. This can enable a split stack. And those DTLS messages for hand manages sent over a specific PPID. And when you want to rekey, you just generate a new DTLS session that derives a new key, performs authentication, all these things. So, and user message fragmentation is done by SFTP is normal because there's one record per SFTP packet basically. So next slide. So what has happened since last? We submitted an update, the draft update. One aspect of this was the replay windows because of multipath or multi-homing and the heartbeat messages being sent over different paths needs to be replay. The replay window needs to be big enough to cover those packets. We also clarified around the p-valid solutions indicator field and the fact that this is an array. If you ever would have more solutions than 32, you would just add another 32 bits for the bit vector. We also clarified how you keep p-valid reliability. So if you lose the p-valid, you retransmit after an RTO timeout. And if this and you continue to do this until your t-valid timer times out, and then says declares the session association establishment as failure. We also clarified how error during handshake error message can be done, used to deal with different situations. And we also clarified what you do if you actually get an SFTP chunk bundled with the DTLS chunk, and that is to ignore the other chunks. And we updated the p-valid protection solution indicator and registry and mandated DTLS replay protection being used. So those are the changes on the DTLS chunk draft. Next slide. On the handshake, there's a few small updates, mostly editorial improvements. We have clarified that if you would actually have this super jumbo record limit, you would basically what this imply would be that you get an IP MTU support for SFTP message up to 64K instead of 16K, which is the current limit. And we also looked at considerations for datagram path packetization layer MTU discovery and how that interacts with the DTLS record overhead and cipher changes, because that can change how big authentication tag, etc. is added. So next. So we have an implementation work on DTLS chunk ongoing. This is actually, we're trying to verify that this works with our intended use within the 3GPP protocols, etc. And we actually have come to the current status is we have initial handshake and data transmissions working on trying rekeying, etc. But that's not fully functional yet. But we expect by next IETF meeting we should be able to have a full report on the successful implementation here. So yeah, next slide. There are a few open issues which was found during the review and preparation of the draft. They are rather minor, most are editorial. I will discuss the first one of the DTLS chunk after this slide, but the other ones we will expect to resolve rather soon in an upcoming update. So because most are editorial in nature. This API need, if you need a queue, is saying how many invocation, if you need to have some help there in that API, this abstract API or not, that's basically the question. Let's go to the next slide so we can discuss the open issue, if anyone has input. So currently for DTLS chunk, all DTLS message coming from the handshake is bypassing the DTLS chunk and sent in their own SFTP packets, unencrypted. So they are only protected what DTLS already provides from protection for these handshake messages, etc. So But when you have managed to establish the first and you have some keys in place, you could actually encrypt these. And the question here really is if you should, when this is possible, should we encrypt it? It has some small benefits in hiding the detailless handshake from direct targeting from any adversary on path. And it would allow them to bundle with other chunks if possible, if they exist, just set them at time of transmission, like hacking and things like that. But the downside here we see if you have any kind of failure so that you can't send encrypted messages, you will have to first as a sender detect that this is happening, and then resend the data handshake message without the association encryption in place, and possibly this without actually being able to use the encryption, etc. So it can make the whole solution a little more brittle from that aspect. So if anyone has any comments on this, we're happy to receive feedback. So. Okay, let's go to the next slide. So on the details over SCTP, here, just as a reminder, so this is what's in the working group document currently. And this is defining details encryption of the user message specifically. Taking user message, fragment it into multiple fragments, each being protected by a details record, and then sending this protected user message over SCTP. And this is defined as an adaptation layer. It is relying on SCTP OAuth to protect the integrity and ensuring that the order of these details records per message, SCTP user message, comes back in the right order on the receiver side. And it also uses the parallel detailless connection for rekeying and using detailless connection IDs for identification. So next slide. The only update, well, we resubmitted the version just to keep it alive. We didn't do any changes. There are a number of issues, but we have been kind of waiting here to see what's on general, what will be the working group's direction on decisions, etc., for details for SCTP before doing much more work here. So, yeah, I think that's the last slide. So, any questions or comments?
Michael Twixen, you made a reference to the, I don't know exactly the name, Super Jumbo
Yes.
datagram thing. The document was recently updated to not be limited by 64K, but to go beyond that. So are you trying to, this document was updated but not presented in TLS. So what are the plans? Are you moving this forward or not? Or
I think I have to, so saying it's for the details chunk, this is unlikely to be needed improvements, because it's the only thing it does is bumps the IPM, saying the SDP MTU from 16K to 64K per packet. And the deployment of larger MTU than for even 4 or 9K is not really an existing where we see this will be deployed. So if that, and most common is like 1500, 1800 MTU. So we don't see a need for it from that perspective. But John maybe have comments on it.
So does that mean you have a document you don't want to progress?
We don't need to progress it, so it's the Super Jumbo, no.
Okay, thank you.
Any other comments?
Okay, please continue the work. It would be nice to see progress on this topic before Dublin. We spent a lot of time preparing the ground for this, and it'd be nice to report on that progress when we come to Dublin. Look forward to that.
Okay.
Okay, thanks, Magnus. The last talk, we will allocate 20 minutes for the talk. So we reserve some time at the end for some working group questions or discussion. Go ahead, John.
Hi, I'm John Kaipalimalil, and I'm presenting the requirements for network collaboration signaling on behalf of my authors, Dan, Sri, Sridharan, Spencer, and Ben. Next slide, please. So I'll take a couple of slides to go through why we have this document, some background and a rationale for it, and then go ahead and present the details of the slides of the signaling itself. So there were a number of drafts over the last 2 years that were proposing collaborative signaling from the host to the network, network to the host, and server to network. And these have been captured in these drafts that have been listed here at the very top. And one of the suggestions from this group was to put all this together in a single draft that captures all of these and the constraints around them. And that was his attempt in this draft. So in the next slide, I can go over the general rationale. For all of these drafts that were in the previous one, the idea was to enhance the perceived quality of experience and an observation that using heuristics and implicit signals may not be sufficient in many use cases that we'll cover in the next few slides, and that a collaborative approach is worth looking at. So that's what I'll cover in the slides that follow. Next slide, please. So an overview of what we're going to cover here. The draft is organized into the introduction and then a set of use cases to motivate the signaling, and a very new section that we've combined the operational consideration of a network for these kinds of requirements, and then the requirements for host to network in section 5 and server to network in section 5.3. Okay. So this is an overview of the end-to-end system and the access network bottlenecks that we're looking at. Two access networks are shown here, the 3GPP mobile network and a wireless or home with an ISP network. And we're looking at the access network as is written over here. And there may be one or more bottlenecks that we're concerned about. From the wireless side, we're concerned about variations in wireless link quality in very short intervals of less than a millisecond. And the aim that when the feedback signal is trying to adjust the rate and other things, that's a bit too late. It might be helpful to send information that can allow the network to collaborate, not just the endpoints. Another aspect is bandwidth. I'm going by on the second point, the bandwidth constraints in terms of the number of concurrent users or exceptional overload. This is a case more or less for signals from the host to the network as to how to handle or what the user thinks should be prioritized. Other aspects include, the interactive media requiring both high throughput and low latency. We're also seeing that traffic patterns can change during a session when we start introducing live media or AI generated content, and the periodicity with which these shapers work may not be so applicable at that point. And the whole idea is that an explicit signal from either the host or the network with these constraints will help the overall utilization. Next slide, please. So to start with here, I'm going to just talk about the operational conditions, and so the network attachment and transport in relation to transport flows. So this is a diagram that's in the draft, but I've just modified it slightly to illustrate over here that a user may have network attachments. I mean, clients 1 and 2 may have network attachments, which run these transport flows that are marked here as flow X1, X2, and X3. And our transport flows for an application A1 or A2. And based on the network attachment, there is a set of QoS and policy constraints that are applied. For example, flow X1 and X2 get the same, an aggregate set of policies and QoS that's applied to both those flows, meaning in terms of shaping and scheduling and so on. We have not gone into the details of how that signaling is applied. I mean, that is for now outside the scope of this draft. You could imagine that in a system like 3GPP, there's signaling to set it up, and that bundle corresponds to a connectivity session that's marked as a network attachment here. But it's not limited to just that one case. We've made it more or less a general system over here. So key points are that one or more flows may coexist in a network attachment, and networks may shape flows distinctly even within that attachment, which is very typical. For example, a high bandwidth using flow may be shaped while others are not. The whole idea is to deliver a high quality of experience for all the flows. Going to the next slide, please. So use cases, I'll just skim through all the use cases. It's documented in detail in the draft, but the motivating ones are media streaming. As, for example, an iframe containing a full video frame should have higher priority. And if it's not available, then the rest of the ones in that group of pictures don't make that much sense sometimes. Interactive media, which in addition also considers highly delay sensitive inputs, examples of XR and group conferencing or P2P voice over IP. The third use case is that a user may have preferences. For example, keystrokes to a server may be important in the case of a game, or while audio may be important in other cases. There may be mixed traffic. That's the fourth use case that we've identified, where an example in the draft is that of a digital model of real world apps, multimedia and interactive engagements. So and in that case, the package of a stream should be treated in the same manner. And the fifth use case is that of honoring metadata for servers behind a gateway, as in the case of enterprise networks. These are all motivating ones, and there may be more, but I think this is good enough to motivate the requirements that we have identified. Going to the next slide. So this is an important section, I think, that now binds together, or whatever is common to both the host to network signaling and also the server to network signaling. These are operational considerations, for example, based on that network attachment and so on, what happens in the network. The aim of the network would be to maximize utilization, whether it be bandwidth or lower latency or some other policy condition. And these requirements identifying what should happen when solutions for the host to network or server to network signaling is put in place. So just quickly skimming through them, policy enforcement, metadata hints from network to client to adjust behavior. They could, when there are multiple such signals, there's a question of classification complications. The third one is about metadata scope, because the network does not generally allocate a quota per application or stream or flow. So how would that be handled? There's multiple bottlenecks probably, as was illustrated in the figure before. The fifth one is about application interference. Um, this may not be the case for all, but in some cases you might have different applications that interfere with others. Privacy is a very big one, that's 4.6. And the main points are that none of the user information or application information should be revealed when you add this metadata. 4.7 is talking about scalability, that the amount of processing that is required should not be excessive. I mean, what we say is it should not scale in the order of the number of flows. We're talking about mobile networks. So in 4.8, when a session moves from one attachment point to another, it should not require a whole lot of effort to set up that the session should continue as before. And then there are constraints and abuse aspects. I mean, constraints in terms of that the network will not be able to provide signaling and prioritization and all of that for every flow it's trying to handle. So these are the operational considerations that we've identified when we're talking about these flows. So going to the next, please. So here, this figure can show you, we're talking about the host to network, network to host, marked in blue signaling over there, and then server to network, as shown in the red section between the server and the UPF. Next slide, please. So the next two slides will cover the host to network and then the server to network. So covering host to network metadata, 5.1 section, two broad requirements, that's priority between flows and priority within a flow. So by priority between flows, we're talking about some flows of the same host being less or more important than that of the same host. We do not try to solve interflow between different hosts. That's a different problem in terms of fairness and other things. That's not covered here. Priority within a flow, for example, in some cases, video may be of higher priority, and in other applications, audio may be of higher priority. Going to section 5.2 with network to host metadata, what the network may signal to host. One is that of assisted offloads, when the network seeks to change resources during a crisis or overload conditions. And I should point out at this point that we're not aiming to create one solution that solves all of these criteria. And maybe some of these requirements apply in some scenarios and not others. So these are things, this is just grouping together all the requirements and constraints that we have to consider. And 5.2.2 is about network bandwidth and rate limiting policies. That's also something that a network is signal to a host. Next page. And here it's the server to network requirements. The aim here is for the server to provide some information to the network in terms of how it would like packets or groups of packets to be handled. The real use case in here is that of media, where a group of packets and the handling of a group of packets should probably share the same fate, not just a single packet. And so it's interesting to identify a media frame or a stream as a group of packets. And that group of packets would have a priority, a relative priority. And some of those frames may be more tolerant to delay or not. And the last one is a little bit different. The wireless networks go to sleep every now and then. And so giving an indication of the burst size and the interval of a burst would be interesting in terms of letting the radio go to sleep and reduce the amount of power consumed. So these are the sets of requirements for both host to network and server to network. And I think the last slide will be to summarize and say what we should do with the next steps. So just to go through it very quickly, this problem has been presented in terms of all those slides which we identified in the very beginning in a number of IETFs from 116 onwards. And there were various recommendations from the group in terms of what we should do. And the last IETF recommendation, working group recommendation was to group these requirements. So there's been a considerable amount of discussion on the solution or of the requirements, I should say, not the solution really. And previous meetings had shown a significant amount of interest. We are interested to see if the group is ready to accept this work as a starting point. Thank you.
Thank you for your presentation, John. And we would like to run a show of hands first to see who has read this document.
And I guess at the same time, we could, let's run it in the meetings tool. Can you, I'll do that. Can you come to the mic if you have any questions for John? We'll run that in parallel.
So I can ask a question now, or?
What's the question? Go ahead
Oh,
if you have a question.
Okay. Yeah. Thanks for the presentation, John. I'm just wondering, have you done an analysis of, because it's a broad set of requirements, and I understand you have collected these requirements from a multitude of previous works. I'm just wondering, have you done an analysis of how many of these requirements are covered by different solutions that might have been specified in different standards bodies? For instance, 3GPP has a lot of work around quality of service, UE route selection policies, etc. You have a lot of L4S work that might be addressing some of these concerns here and so on. So I would like very much to see an analysis of, like, out of these requirements, what is covered by already existing mechanisms, and why are those not sufficient to handle these problems? So because right now it's a huge set of things here that I'm not sure that all of them needs the same amount of attention and focus.
I can just, yeah, thanks, Marcus. I agree with you. I mean, the aim was to put these requirements together, and especially looking at it with the 3GPP side, there are a number of capabilities, for example, on the host to network side, which 3GPP has got an extensive amount of signaling to set up, the different criteria, user route selection policies and all of that. So yeah, we can maybe give an analysis as to, or we probably won't be able to capture every use case, but at least we should be able to say what's covered in some of these major deployments like 3GPP or an enterprise network, and say what would be applicable where. Yeah, that's a good comment, and we'll look at it for sure.
Marcus, were you potentially volunteering to help in this process? Do you think you have time?
I probably don't have time to write it up, but I'll be happy to review and make comments if you do that work.
Thank you.
Thank you.
I've closed the show of hands. We had 13 people indicating that they have read the draft.
Carry on with the mic.
Hi, Altana Komiraki. Extending the previous question, how does this system differ from the existing data plane-based flow identification, such as the IETF IPFix protocol, which is based on Cisco NetFlow? Basically, you are indicating a control plane-based signaling. How is that going to be better than a data plane-based signaling that already exists and is used?
Right. Okay. I would say that this signaling is not, I mean, it is controlled signaling, but it is a side, I mean, we expect it to be a side channel to the data flow itself. So it would be, I mean, I wouldn't say, I mean, maybe in-band is one way to say it, depending on the solution, but we're only presenting the problem at this point. So I would imagine we use a side channel like UDP options or like DSCP. I mean, it would depend on the solution, and but it's not a separate control channel, if that's, yeah.
So you're saying you can use IPFix?
I'm sorry, there's a lot of echo, so I couldn't follow.
Okay, I'm saying, so you're saying you can use IPFix or no? This is not that.
No, I don't think, I mean, that would be a solution space, and we should allow people to look at that, but we would need some signaling that crosses network domains.
Kazuhoku, thank you for writing the draft. I think it's very good to have use cases and constraints being written down. But I think it's a separate question if we should work on solving these issues or if this working group is the appropriate location, considering that there are things like comparables that's working on a specific use case of one of these requirements. So I think my question is this an attempt to write down a requirements document that lists what the working group should be working on? Or is it about writing down what could potentially be done? And I'd be very much relieved if it's the latter.
I'll clarify as a chair. What we pushed back on was we didn't want to see a particular solution. I mean, we obviously want people to have solutions in mind. What we wanted to know was the requirements in this space, the opportunities of getting some benefit from different techniques, and to somehow know if this is a sort of work that could be done here. Because I think over the time I've chaired TSVWG, this has come up every 10 years. Looking backwards, still coming up. You know, are we at this place now where we can actually write down some requirements, some use cases that are potential, some potential solutions, and understand the privacy concerns, the operational concerns, and the potential benefit? Does that answer?
Thank you, it does. I hope that it will be more clear that it's not the case. But thank you.
Michael.
Michael Wetzler, I think this is a very interesting document indeed, especially the signaling from the server or the client to the network. However, I have a gut feeling that this list that you're presenting on all the requirements of things that need to be signaled is too long. And I think it would be, I don't want to suggest that you go into solutions, but I think we should have at least an example for each of these things of where somebody has done that, you know, like a research paper, some industrial development or something. For example, I got this thought when thinking about the very last item you had, which was the burst size for putting devices to sleep. I mean, that is an example that sounds very useful, right? But if you think about it, I mean, at least I don't know what I would do with that information, because right now there are ways to just put the device to sleep after transmission is over. So I would have to be convinced that there is something useful to be done with that kind of information before seeing a document that lists it. And I think it would make sense to go through the whole list in that same way and just prune it a little bit and get rid of things that are maybe not so convincing, because some are clearly very convincing and you know, clear cases, but some are less clear. So I think that would make the overall document more convincing.
Thanks. It's a little bit in line with what Marcus also mentioned. I mean, in terms of, I mean, it's complementary in a way. And maybe we can have an analysis in an appendix of some sort so that we capture, or we can discuss how we should document this.
Yeah. Okay. Thank you.
Kenji, CMCC here. I briefly read through the document. I think it's interesting. I know all the history about the things here. I'm glad you mentioned about the mobile case here. Actually, I'm thinking like a host to network to host the kind of things. But for the case you mentioned, the 3GPP, it's more like a network to network. But this network is not direct connected. There are some feedback mechanism. The run network is going to get it and send back to the core for core to access. This is like an LFS. Well, I'll give a specific example. So this is for you to consider. It's like a, not host to network, but something maybe from like access network to a core network, the feedback, for you to digest. Obviously, this is good work, or just, there's something. Another thing is like, I'd like you to review their RFC published by IAB. It's RFC 9419. Yeah, the title is Consideration on Application Network Collaboration using Path Signals. So that RFC has already laid down some principles that can be done, but that is not in any group, but from IAB. It's RFC 9419. It's like a application to network application to network collaboration using path signals. Thank you.
If I may respond.
Yeah.
Okay. So 9419 is something that we have referred to, and I guess, definitely agree with you on that we should, there are other constraints which we have not elaborated on, but just referred to 9419. So that's great. On the first one, the comment, I would like to say that what's between the 3GPP core and the access may not be of specific interest to the IETF at large, because it's within, it's something that 3GPP can deal with. So this is looking at the broader endpoints and network as it applies to the IETF.
Okay, a reminder that this proposal here is likely targeting an informational document about the requirements and opportunities, not the solution space. And before I say more, I will let Zahid speak if he wishes.
Yeah, Jahid. So I have a couple of things to say, actually. So first of all, thank you. I think I was kind of like pushing, like put the documents together so that we can have a common view. And I'm hearing like now we have too much in one place. But that tells me one thing. I mean, one of the things that I think like would be very beneficial is actually to see these use cases, like elaborate on those use cases, and I mean what benefits they do, and how. So kind of gap analysis on an IETF protocol level, like how we would achieve that one. So that would be like one interesting thing to. I don't know, like if it is a document thing, it's like PowerPoint work, but follow up things. But I would like to see those, like so that we can actually judge like how important those. If we do this kind of signaling, if we define something like for streaming media and stuff like that, or any kind of use case that you're talking about, that how much we are adding up, how much we are making sense basically, if we devise something, and what is already there in IETF that actually covers that. So like, okay, we have already protocols and signals to cover those kind of, we can reduce the number of things there. That's one thing. And now I think the other question, like more kind of an Eddie question, is like, I would like to see like clearly where we are going with this. From the, I mean, as Gauri you mentioned, like this is kind of like we want to like to know, like, I mean, I don't think like we should really consider like how we publish these things, information or whatnot. This is, I think, a discussion point right now, like whether, I mean, Kaju has a good point, saying like, is this something that we should work on this working group, or we form new working group or something like that. But base work could be done here, like looking into the use cases, gap analysis, and requirements. We can see like, okay, this is something that we would like to work on. The other thing that I'm thinking, like some of the, if you look a bit details on like some of the use cases and requirements, they are going from per flow to per packet level costs. And this is something like what is not is kind of absent right now, because my understanding we're talking about flow level, quality of service, and all these things. So that's another kind of the question that we should drive to see, like whether we'd like to go for that kind of granularity of quality of service or not, and how you actually achieve that kind of things. So there are a couple of things here. I think we should really focus on what we're getting out of this work, so that we use our time in a good way and where we want to go. It's a bit not clear to me right now, so maybe something to work with in the authors and the working group and the chairs to set that up. Make sense?
Would you like to ask the working group a question about the potential to work on that topic? Or do you want to wait until a document emerges which has that content that you want?
Well, right now, I don't think like we're asking anything. We're sharing the information, right? But then let the share information come and see, and we have discussion more, rather than we try to understand like what we are doing here with a goal like what we want to achieve. Because now we have this document that's good for education and good for understanding, good for bringing information. But where do we want to go with this? So we need to figure it out so that we understand what we're doing.
So you'd like a new document that is focused on the on what we might publish, I guess, rather than providing a background to it. Is that right?
So I'm not talking about document here, Gauri. I mean, this is not only thing about the document. This is about the discussion. This is about the content of the thing that I want to say that we are doing, and also like kind of like from like management point of view, what we want to drive with this, all these things that we're doing in this, because it's still not clear to me like how much we should do here and what we ask to do here, right? So kind of focus on that kind of the goal that we want to achieve, and also back that up with either document or presentation or like research. I don't know, like more data, perhaps. Like you said, John, like 3GPP doing something. If they have already like way of achieving what they want, what we should do here then. So that's also like kind of like a question, right? Somewhere need to be answered.
Right. Yeah, there is some coupling over there that we have to look at. Yeah.
Yeah.
Yeah. I mean, clearly we can put that in the document somewhere.
Yeah, sure.
I think it'll also be useful to get people thinking about the solution if we were to have an understanding that we would work on some of this, maybe not all of this, but some of this. So I think it would be better to drive that. I mean, given all the comments and constraints that we've addressed today in terms of, not duplicating things, or that there should be research that's backing it, and also a clear, but even so, I think it'd be useful to have this.
Yeah. I completely with you on that one. It's just like we might need to reduce and focus and see like what's the solution might look like, and think about the philosophy of quality of service and all these things and improvement that you want to do. Yeah, thank you. I think you got very good comments today, actually.
Thank you.
So, from the audience.
Okay, thanks, John. We have come to the end of our meeting slot. It was really good to see people here on Friday. That was very good to turn up, and we would love to see more discussion on the list regarding the drafts we have in this working group. Thanks very much. Keep using the list, and we'll see you in Dublin. got outside, I think. Read his mind. Okay.